In the previous session, I have shown you 17 problems so far, the previous sessions. So I have given the question number 4 to 17 in a row. I have given problems numbering from question number 4 to question number 17 in my previous class. I have given the answers for all the problems, and I have already discussed some of the problems. So I am now going to show you two more problems on the screen. After reading each problem, you can take a pause and try the problem for 1 or 2 minutes, or in case you require more time, little more time. Then you can check up the answers. Then after these two problems, I will be discussing the other questions which are shown on the screen in my previous class, which I have not discussed. So some of the students might have already solved the other questions which I have not discussed in my previous session. So now look at the question number 18. Two forces P bar and Q bar having same magnitude of 10 Newton, and the magnitude of the resultant is 10√3 Newton. Find the angle between the P bar and Q bar, and also angle made by the resultant with P bar. Come on, take a pause and try this problem yourself. The answer for this question is 60 degrees. I mean, angle between P bar and Q bar is 60 degrees. And the angle made by the resultant with P bar is 30 degrees. Look at the next question here on the screen. The magnitude of the resultant of two forces P bar and Q bar is R bar. The resultant R bar makes angles 30 degrees and 15 degrees with P bar and Q bar respectively. If R equal to 10√2 Newton, then Q equal to, you can look at the options for this problem. First option 10 Newton, second option 20 Newton, third option 10√2 Newton, fourth option 10 into √6 minus √2 Newton. Come and try this problem yourself. This problem is more interesting than the previous one. You can take a pause and try the problem. Now, answer for this question is the first option 10 Newton. Now I am going to discuss the remaining problems in the numbers 4 to 19, which I have not discussed in my previous session. But those students who have already solved all the remaining questions that were shown on the screen in my previous session, they can skip this session now they can directly go to the next session on the computer. So, but those students who need explanation, who want explanation, even for other questions which I have not discussed in the previous session, I am going to discuss them now. So, the question numbers which I have already discussed in my previous session are, I have discussed the question numbers 8, 9, 10, 11, and 17. Now I am going to discuss the remaining, most of the remaining questions. You can see my working on the screen. So those students who have already solved the problem, already got the answers. And those who don't need explanation for other problems, they can skip this session and they can go to the next session. Come on, look at the solution. First, I am going to discuss the question number 19. Just shown in the last. The last one I am going to discuss first now. So look at the question number 19, which I have shown you in the last, the list of the problems. It's given that the resultant of the two forces P bar and Q bar is R bar. And it is also given that the magnitude of the resultant, which is denoted by R, equal 10√2 Newton. It's given that the resultant R bar makes angles 30 degrees and 15 degrees with P bar and Q bar respectively. Let alpha denote the angle made by the resultant vector R bar with the first vector P bar. Let beta be the angle made by the resultant R bar with second vector Q bar. So, from parallelogram law of addition of vectors, the two vectors P bar and Q bar are suppose represented graphically by the adjacent sides of the parallelogram, such that tail of vector P bar is attached to tail of vector Q bar. And the diagonal of the parallelogram passing through their point of intersection represent their vector sum or resultant. So the direct line segment OA bar represent the first vector P bar. So given that the resultant R bar makes an angle alpha with the first vector P bar. So here OACB is a parallelogram. The direct line segment OB bar represents second vector Q bar. The direct line segment OA bar represents first vector P bar. The direct line segment OC bar along the diagonal of the parallelogram represents the resultant R bar. So the line AC is parallel to the line OB in a parallelogram. Opposite sides are parallel. So therefore this angle will be same as this angle. In a parallelogram, opposite sides are equal. So AC bar is equal to OB bar, which is equal to Q bar. So this angle is also beta. So here, in this triangle OAC, angle at this vertex is alpha, angle at this vertex is beta. So the angle at this vertex will be equal to 180 degrees minus alpha plus beta. Alpha plus beta gives you the angle theta between the two vectors p bar and q bar. That will be equal to 30 degrees plus 50 degrees equal to 45 degrees. So this problem can be solved by two ways. One method is by applying the sine rule for the triangle OAC. The other method is by using the expressions for magnitude and direction of the resultant of the two vectors. So let us come to the first method. From sine rule in the triangle OAC, the length of the side OA divided by sine of the angle at the opposite vertex will be equal to length of side AC divided by sine of the angle at the opposite vertex is equal to length of the side OC divided by sine of the angle at the opposite vertex. So length of the line OA gives you magnitude of P bar or P. The angle at the opposite vertex is beta. The length of the side AC gives you magnitude of Q bar or Q. Angle at the opposite vertex is alpha. Length of the side OC gives you magnitude of the resultant denoted by R. Divided by sine of the angle at the opposite vertex is 180 degrees minus alpha plus beta. You are asked to find the value of Q. So we consider the last two. So Q can be written as R sine alpha by sine of alpha plus beta. That means we have used the trigonometric relation sine 180 degrees minus theta equal to sine theta. Here alpha plus the beta can be written as theta, which is the angle between P bar and Q bar. Therefore, you get now substituting the values R equal to 10 root 2 Newton, alpha equal to 30 degrees by sine theta is sine 45 degrees. You can substitute the value of sine 30 degrees equal to 1 by 2 and sine 45 degrees is equal to 1 by root 2. We simplify this, you get Q equal to 10 Newton. That's the answer for the problem. You can just go through the solution once. Of course, in this problem, you are asked only to find the value of Q. But in case you are asked to find the value of P also, you can find it by combining the first and last, or by combining using the first two, because the value of beta is also given in the problem. Next, I would like to discuss the same problem by the alternate method, that is by using the expressions for direction of the resultant and magnitude of the resultant, because some students may get a doubt, why not we solve this problem in the similar way as we have done earlier problems. So this problem can also be done by the similar method as I discussed in the earlier problems. So I am going to discuss this same problem by the alternate method also. Come on, look for the alternate method on the screen. Now look for the alternate method for the same problem. So you look at the diagram I have drawn in the earlier question, in the earlier methods. Of course, this diagram should be again drawn even in this method. Here also, that means up to this, you have to write the same steps even for the alternate method. That is the angle theta between P bar and Q bar can be written as alpha plus beta. That is equal to 30 degrees plus 15 degrees equal to 45 degrees. So the alpha is given to be 30 degrees. So here you are asked to find the value of Q. You are given the value of R, but you are not given the value of P. Therefore, here both P and Q are unknown quantities for the beginning of the problem in the alternate method. So you cannot solve for both P and Q from single equation R square equal to P square plus Q square plus 2PQ cos theta. Therefore, we try to express P in terms of Q first by using the formula for the direction of the resultant. So theta is 45 degrees, alpha is 30 degrees. So as you know, if alpha is the angle made by the resultant of the two vectors with the first vector P bar, we know the formula tan alpha equal to Q sin theta by P plus Q cos theta. Here you can substitute alpha equal to 30 degrees on the left hand side and theta equal to 45 degrees on the right hand side. So tan 30 degrees can write as 1 by root 3. Sin 45 degrees equal to 1 by root 2. Cos 45 degrees also 1 by root 2. You can solve for P in terms of Q from this equation. You can write P plus Q into 1 by root 2 equal to Q into root 3 by root 2. So you get P equal to Q by root 2 into root 3 minus 1 from same equation. That means if you carry this term to the right hand side, you get this. Then you have expressed here P in terms of Q. Now we can use the formula for the magnitude of the resultant of the two vectors. As you have discussed in the past, R equal to root of P square plus Q square plus 2PQ cos theta. Or otherwise you can write R square equal to P square plus Q square plus 2PQ cos theta. Here you can substitute here P equal to Q into root 3 minus 1 divided by root 2. That is this value on the right hand side. Plus Q. Again in the here also you can substitute the value of P equal to Q into root 3 minus 1 by root 2. And theta equal to 45 degrees. And you have to of course substitute the value of cos 45 degrees equal to 1 by root 2. And you have to simplify the right hand side of this equation. You can do that yourself. You have to do the simplification carefully. Finally, you get R square in terms of Q square after simplification. If you complete the simplification yourself, you can try to complete the simplification yourself here. If you want, you can take a pause and try to complete the simplification. You can take Q square common on the right hand side and simplify the terms. So you get Q square into root 3 minus 1 whole square by 2 plus 1. This is the value of p which I have substituted here in place of p. Of course, you should also write q here. Plus 1. You get 2 into root 3 minus 1 by root 2. Cos 45 degrees is 1 by root 2. So this you can simplify further. You get r square equal to q square after simplification. You're supposed to get r square equal to q square or q square equal to r square by 2 or q equal to r by root 2. Now it's given that the value of r is 10 root 2 Newton. So you can substitute the value of r equal to 10 root 2 Newton. You to get the answer, same answer. That means you get the same answer, that is q equal to 10 newtons. Okay. So in this question number 16, you are given that magnitude of p bar by 5 equal to magnitude of q bar by 4 equal to 1/3 of magnitude of the resultant of p bar and q bar. I denote each ratio by n. So we can write magnitude of p bar from first and last equal to 5n. Then from second and last, you can write magnitude of q bar equal to 4n. From the last two, we can write magnitude of the resultant of p bar and q bar equal to 3n. Can solve this problem by any one of the two methods. One method is by using the triangle law of addition of vectors. The other method is by using the parallelogram law of addition of vectors. So I will be discussing the first method, that is by using the triangle law of addition of vectors. So when you want to solve the problem by the triangle law of addition of vectors, you can first initially check up whether the three given magnitudes satisfy the condition of Pythagoras theorem for right angle triangle. That means you can check up by adding the squares of the smaller magnitudes. If the sum of the squares of smaller magnitudes, if it becomes equal to the square of the largest magnitude, then you can conclude that they form a right angle triangle. But in every example, you may not get a right angle triangle. For example, in the previous problem, that is the question number 19, which I have solved before this question, p bar, q bar and r bar do not form a right angle triangle. In such cases, if you want to solve the problem by triangle law of addition of vectors, you can apply the sign rule as we have discussed in the previous question. But here, you can observe that the three given magnitudes satisfy the condition of Pythagoras theorem. If you square the magnitudes of the vector q bar and resultant and add them, 3n square plus 4n square, that is 9n square plus 16n square equal to 25n square, that will be equal to square of the magnitude of first vector p bar. Therefore, in this case, the vectors p bar, q bar and resultant can be represented along the three sides of the right angle triangle. So before you draw the right angle triangle, you have to see that, you must remember that the vector which has largest magnitude should be represented along the hypotenuse side. Here vector p bar has largest magnitude, so it should be represented along the hypotenuse side. The smaller magnitudes must be represented by these smaller sides which are perpendicular to each other. That means in this case, the resultant of p bar and q bar is perpendicular to q bar. So the first vector p bar which has largest magnitude should be represented along the hypotenuse side. Cutting triangle law of addition vectors, the two vectors p bar and q bar are graphically represented by the two sides of the triangle taken in the same order, means head of p bar attached to the tail of vector q bar. Then the third side of the triangle taken in the reversed order represent the resultant vector. That means if you imagine that these two vectors p bar and q bar are two displacements, particle displaced from here to here, which is represented by p bar. Next it is displaced from here to here, which is represented by q bar. Then this is the initial position of the particle, this is the final position of the particle. So magnitude of the resultant displacement is the shortest distance between the initial and final positions. The third side of the triangle taken in the reverse order represents the resultant. That means tail of the resultant should be attached to the tail of first vector p bar. Head of the resultant should be attached to head of second vector q bar. The figure r bar represents the resultant of p bar and q bar, which is perpendicular to the vector q bar. Now, to know the angle between two vectors by the graphical method, the two vectors must be graphically represented such that the tail of one vector is attached to the tail of other vector. So here, this angle, call it as alpha. That means alpha is the angle between resultant and first vector p bar. So this angle will be equal to, in this right angle triangle, 90 minus alpha. So let us call this angle for convenience as theta 1. So in this triangle, you can observe from the figure, sin theta 1 is equal to length of the side opposite to the angle theta 1 divided by length of the hypotenuse side. Length of side opposite to the angle theta 1 equal to magnitude of the resultant of p bar and q bar, and length of the hypotenuse side is equal to magnitude of p bar. So we can write magnitude of the resultant of p bar and q bar equal to 3n from here, and magnitude of p bar equal to 5n. So that is 3n by 5n. That means you get sin theta 1 equal to 3 by 5. So we know it is given that sin 37 degrees is equal to 3 by 5. So theta 1 is equal to 37 degrees. But theta 1 should not be taken as the angle between p bar and q bar. As I discussed in the past, to know the angle theta between two vectors p bar and q bar, the two vectors p bar and q bar must be graphically represented such that tail of p bar is attached to tail of q bar. You can graphically draw a given vector at a different place in diagram without changing its magnitude and direction. So you can draw the same vector p bar here also. That means you can attach tail of p bar with the tail of q bar. So this is the angle theta between p bar and q bar. So you can observe that the angle theta between p bar and q bar will be 180 degrees minus theta 1, or 180 degrees minus 37 degrees. That means angle between p bar and q bar equal to 143 degrees. So that is one of the answers. Next, we are also asked to find the angle made by the resultant with the first vector p bar. That means you have to find the angle alpha in the figure. In the given figure, in this figure, you can observe that sum of the three angles alpha plus theta 1 plus 90 degrees will be equal to 180 degrees. That means alpha, one angle is 90 degrees. So sum of these two angles alpha plus theta 1 will be equal to 90 degrees. So alpha equal to 90 degrees minus theta 1. We got the value of theta 1 here as 37 degrees. We substitute here. So get alpha as 53 degrees. This is another answer. That means alpha represents the angle between resultant of the two vectors p bar and q bar and the first vector p bar. So that is 53 degrees. So if you want time to copy the solution of the problem, you can take a pause and copy the solution of the problem. So I am again solving the same problem by an alternate method, that is by using the parallelogram law of additional vectors, that is by making use of the expressions for magnitude of the resultant and direction of the resultant. So given that, again starting from beginning, magnitude of p bar by 5 equal to magnitude of q bar by 4, that is equal to magnitude of resultant of p bar and q bar by 3. Let us suppose each ratio be equal to n. So just as I discussed the previous method, here also we can write magnitude of p bar or p equal to 5n, magnitude of q bar or q equal to 4n, and magnitude of the resultant of p bar and q bar equal to 3n. Now if theta is the angle between the vectors p bar and q bar, then we know that square of the magnitude of the resultant of p bar and q bar equal to p square plus q square plus 2pq cos theta. So on the left hand side, you can substitute magnitude of the resultant of p bar and q bar equal to 3n. On the right hand side, you can substitute p equal to 5n and q equal to 4n. Here also again you can substitute p equal to 5n and q equal to 4n. So this you can try to simplify further. So this is 9n square, taking these two terms to left side, minus 25 plus 16 will be 41. That is equal to 40n square cos theta. So this you can write minus 32n square divided by 40n square equal to cos theta. So you get cos theta equal to minus 4 by 5. We know that the value of cos 37 degrees is 4 by 5. That means cos theta equal to minus cos 37 degrees. As I discussed the trigonometric relation, cos 180 degrees minus theta is equal to cos theta. Therefore, you can write cos theta minus cos 37 degrees. You can write cos of 180 minus 37 degrees. That means cos theta can be written as cos 143 degrees. That means angle between P bar and Q bar is denoted by theta equal to 143 degrees. That is the answer for the first part. Then next, we use the equation for direction of the resultant. If alpha is the angle made by the resultant of the two vectors P bar and Q bar, with the first vector P bar, then tan alpha equal to Q sin theta by P plus Q cos theta. So here Q equal to 4n and theta is equal to 143 degrees, which you can write 180 minus 37 degrees. And P equal to, you can substitute 5n again. And Q equal to 4n. And theta you can write 180 minus 37 degrees. 143 degrees, you can write 180 minus 37 degrees for convenience of calculation, because you are given the values of sin 37 degrees and cos 37 degrees in the list of the problems. So here you have to write cos theta. Sorry for the correction. Here also you should write cos. That is tan alpha is Q sin theta by P plus Q cos theta. So here also you should write cos. So sin 180 minus 37 degrees, you can write sin 37 degrees. So you are using the formula in trigonometry. Sin 180 minus theta equals sin theta. Cos 180 minus 37 degrees, you can write minus cos 37 degrees. Now you can substitute sin 37 degrees equal to 3 by 5. And cos 37 degrees, you can write 4 by 5. So you can simplify this further. You get tan alpha equal 12 by 25 minus 16, 9. Or tan alpha you get 4 by 3. So from this you get alpha equal to 53 degrees. That means the angle made by the resultant of the two vectors P bar and Q bar with the first vector P bar is 53. So this is the answer for second part of the question. Those who want to copy the solution of the problem, they can take a pause and copy the solution of the problem. After this, I am going to next discuss the previous question, that is question number 15. So next I am going to discuss the problem number 12, which I have given in the previous session. Here it is given that magnitude of P bar equal to 1 by root 3 times magnitude of Q bar. That is same as the magnitude of the resultant of P bar and Q bar. Even in this problem, you are asked to find the angle between P bar and Q bar. and also the angle between P bar and resultant of P bar and Q bar. So we can denote each of the given values as n. That means combining first and last, you can see that magnitude of P bar or P equal to n. Combining second and last, magnitude of Q bar by root 3 equal to n. So magnitude of Q bar or Q can be written as n root 3. And magnitude of the resultant of P bar and Q bar equal to n. So if theta is the angle between the vectors P bar and Q bar, then using the expression for magnitude of the resultant, can write square of the magnitude of the resultant of P bar and Q bar equal to P square plus Q square plus 2PQ cos theta. Here theta is the angle between P bar and Q bar. So here you can substitute magnitude of P bar plus Q bar equal to n on the left hand side. And P is also equal to n on the right side. And Q equal to n root 3 on the right side. Therefore, n square equal to n square plus n root 3 whole square plus 2n into n root 3 into cos theta. So if you simplify this, you get minus 3n square by 2 root 3n square equal to cos theta. Or you get cos theta equal to minus root 3 by 2. We know that the value of cos 30 degrees equal to root 3 by 2. The value of cos 30 degrees equal to root 3 by 2. So you get cos theta equal to minus cos 30 degrees. So as you know, cos 180 degrees minus theta equal to minus cos theta. So cos 30 degrees can be written as cos of 180 degrees minus 30 degrees. That means the angle theta can be written as equal to 180 degrees minus 30 degrees or 150 degrees. That means here angle between P bar and Q bar is theta, that is 150 degrees. Next we are going to find the angle alpha made by the resultant of the two vectors with the first vector P bar. So if alpha is the angle made by the resultant of the two vectors with the first vector P bar, then tan alpha can be written as Q sin theta by P plus Q cos theta. So if alpha is the angle made by the resultant of the two vectors P bar and Q bar with the first vector P bar, you can write tan alpha equal to Q sin theta by P plus Q cos theta. Here you can substitute P equal to n and Q equal to n root 3. Theta I can write 150 degrees. Or for convenience you can write it as 180 degrees minus 30 degrees. So Q equal to n root 3. Theta equal to 180 degrees minus 30 degrees by P equal to n. Q is equal to n root 3. Theta equal to 180 degrees minus 30 degrees. Using the relation in trigonometry, sin 180 degrees minus theta equal to sin theta. So sin 180 degrees minus 30 degrees will be same as sin 30 degrees by n plus n root 3 cos 180 degrees minus theta is minus cos theta. So cos 180 degrees minus 30 degrees, you can write minus cos 30 degrees. Then you can substitute here the values of sine 30 degrees and cos 30 degrees. You can simplify it further. You get the value of tan alpha, right? So you get here n root 3 by 2 divided by minus n by 2. So you get tan alpha equal to minus root 3. That means tan alpha is equal to minus tan 60 degrees. So you get alpha equal to 180 minus 60 degrees. Or you can say alpha is 120 degrees. That means here I have used the formula tan 180 degrees minus theta equal to minus tan theta. So minus tan 60 degrees can be the tan of 180 minus 60 degrees or 120 degrees. So alpha is 120 degrees. So here alpha is the angle between the resultant and first vector p bar. So angle between resultant and first vector p bar is 120 degrees. So this is the answer for second part of the question. So the answers are 150 degrees and 120 degrees. If you want, you can copy the solution. You can take a pause and copy the solution. Now look at the question number 6 here. It's given that magnitude of p bar plus q bar equal to magnitude of q bar minus magnitude of p bar. You are asked to find the angle between the vectors p bar and q bar, and also the angle between the resultant and first vector p bar. So this question can be answered if you are familiar with the special cases in the parallelogram law of addition of vectors, which was already discussed for you. So in one of the special case 2, I have dictated one conclusion. I have given you one conclusion that if two vectors p bar and q bar with different magnitudes, suppose act in the opposite directions, then the magnitude of their vector sum or resultant will be equal to the ordinary difference of their magnitudes. So if you remember this conclusion, that magnitude of the vector sum or resultant of two vectors will be equal to the ordinary difference of the magnitudes of the two vectors only when the two vectors act in opposite directions. So from the given information, you can directly conclude that vector p bar is opposite to vector q bar. And you must be knowing that modulus of vector cannot be negative. As I discussed in the beginning, that the magnitude or modulus of the vector cannot be negative. So magnitude of the resultant of p bar and q bar is also positive. So it is given that modulus of the resultant of the two vectors is equal to modulus of q bar minus modulus of p bar. So this implies that modulus of q bar is greater than modulus of p bar. And it also implies that p bar and q bar act in opposite directions. So you can represent the two vectors graphically by two direct line segments in opposite directions. That means angle between P bar and Q bar is 180 degrees. As I discussed, one conclusion in this case 2, that in general, if two vectors of different magnitudes act in opposite directions, then the direction of their vector sum or resultant will be same as the direction of the vector with greater magnitude. Here, the two vectors P bar and Q bar act in opposite directions, and magnitude of Q bar is greater than magnitude of P bar. Therefore, direction of the vector sum or resultant of P bar and Q bar will be in the direction of vector Q bar. Means resultant of P bar and Q bar has same direction as the second vector Q bar with larger magnitude. Therefore, angle between Q bar and resultant is 0. But the resultant of the two vectors P bar and Q bar, you can observe, acts opposite to P bar. Therefore, angle between P bar and resultant of P bar and Q bar is also 180 degrees. See, this is one answer, this is one answer. You can find the angle theta between P bar and Q bar mathematically by different way without directly using the conclusions of special case. That means in case similar problem is given in subjective type examination, you have to do different way. This approach you can follow for objective type questions or multiple choice questions. In case similar problem is given in subjective type in board examination, you are expected to solve this way. It's given that magnitude of the resultant of P bar and Q bar equal to mod of Q bar minus mod of P bar, which you can write it as Q minus P. If you just write letter P without the bar symbol, it represents magnitude of P bar. Just write letter Q without bar symbol, represents magnitude of Q bar. If theta is the angle between the vectors P bar and Q bar, then you can write the left hand side as magnitude of P bar plus Q bar equal to root of P square plus Q square plus 2PQ cos theta equal to Q minus P. Now you can square both sides of this equation. If you square both sides of this equation, you get P square plus Q square plus 2PQ cos theta equal to Q minus P whole square. Can solve for cos theta. 2PQ cos theta equal to Q minus P whole square. I can be now Q square plus P square minus 2PQ. And if you carry the first two terms, P bar and plus Q bar, on the left hand side to the right side. So you get cos theta equal to minus 1. Must be knowing that the value of cos 180 degrees is minus 1. So theta is 180 degrees. That means the angle between P bar and Q bar is 180 degrees. So here I have discussed most of the problems which I have listed in my previous class, except one or two questions which are of same models as the other questions which I have discussed. So those who want to develop problem solving ability, particularly those who feel they are very average or below average, after taking some time gap, after they can try these problems themselves without looking for the solutions, without going to the solutions again. They can try these problems themselves. So of course, at the end of the topic vectors, I will be giving you the assignment with objective questions in vectors, which you can also practice. So in my next class, I am going to discuss about the components of vector and how a vector can be expressed in terms of its two rectangular components along the coordinate axis, etc. Okay, we'll continue the next class.